Sorry, guys, I had to restart because I was actually starting down here rather than up here. So the idea here is you want to provide a second equation that makes this system of equations have no solutions. And the idea here is that you need the same slope but different y-intercepts, right? So all I need to do is make sure that I have this as negative 7/2 x, and then give a different number here. It could be 0, it could be negative 4, it could be 12, minus 12, really anything, right? As long as this is the same as that, as long as the slopes are the same and the y-intercepts are different, then you're good, right? And so the explanation would be the same slope and different y-intercepts. It means the lines are parallel and have no solution. Okay. And then we kind of move on, and we're down here with one solution. So the idea with one solution is that your slopes will be different, and that's really it. Okay. So as long as your slope is different, then your line is going to be the lines will cross once, right? You could have the same number for the y-intercept, different numbers, doesn't really matter, right? So I'm just going to say y equals, well, let's just do this, 5x plus 100. Let's go with the previous example that I was going to do, okay? Again, it could be plus 4 right here, it could be the same one. What matters is that the slopes are different here, that 5 and that negative 7/2, okay? So here, for the explanation, you would see same slope means the lines cross once. Okay, now moving on to number 8. It's actually very similar, right? Consider this system of equations. How many points of intersection does this have? Well, look here, we have the same slope. And here we have different y-intercepts. That means the lines don't cross at all, so there are no points of intersection. And then a different way to say that is the next part. How many solutions does it have? It has 0 solutions. Okay. And we talked about this in the exact same, this is the exact same thing right here. Okay. When we move on to the second one, right, we see that we have different y-intercepts. Different y-intercepts. No, we have different slopes. Okay. Doesn't matter what these numbers are. It can be the same, but if the slopes are different, how many points of intersection does it have? They intersect once. Okay, so the lines will cross once. So 1 point of intersection. How many solutions? It would be 1 solution right there. Okay. All right, number 9, we have 2 scooter rental places in town. Scooter Central charging $10 to rent a scooter and $5.60 per hour. And we got World of Scooters with $8 to rent and then $6.10 per hour. So I'm going to define my variables as X being the number of hours, Y being the total cost. So for Scooter Central, I'm going to start, actually, they're both going to be Y equals. So we got Scooter Central and we got World of Scooters, right? So they're both going to be Y equals. Now, Scooter Central has a $5.60 per hour, and that per hour matches to the X because it's got hours in it. So that's $5.60. X plus 10, because that's your initial value or your y-intercept. And then we follow a similar pattern right there. So it's going to be 610X for World of Scooters, because again, 610 is how much they charge per hour. And then it's going to be 8. Okay. And so the idea here is that you take this part of the equation and set it equal to that part of the equation. Okay. So I got 610X plus 8 equals 560X plus 10. And then I'm just going to solve this equation like normally. So I'm going to take that 560, clear. Okay, I'm going to take that 560 and I'm going to subtract it to the other side. Okay, so it becomes 610 minus 5.6 gets you to 0.5x plus 8 equals 10. Okay. I'm going to take that 8, I'm going to subtract it to the other side, and I get to 0.5x equals 2. And I divide by 0.5. Okay. And then, I'm just going to do that on the computer. 2 divided by 0.5 gets me to 4 hours. Because the x is the hours, right? X is number of hours, right? So that's 4 hours, and honestly, that is all we need. Okay. So on the test, it's going to ask you to just put in the number. So that's what you're going to do, right? So that's your solution right there, is just to put it in that box. Technically, if you're going to write a sentence, it'd be like 4 hours is the time at which both scooters charge the same amount. So select the irrational number. So if your decimal ends like this, you can change it into a fraction. Okay. So that's going to be rational, not irrational. Okay. Irrational just means you can't make it into a fraction. Okay. This has a pattern to it. It just is 8 going on forever. So since it has a pattern, that's rational. Square root of 36 is going to be either positive or negative 6. If you look at the square list of perfect squares on the back wall, okay, we look at this, we get this 35. It's not on the list of perfect squares. And if I put this into my calculator, let's keep zooming in, I take the square root and I put in 35 and I get 5.91, etc. So this number goes on forever and has no pattern. So that's what makes this one, oh, this one's rational, by the way, my bad. So the fact that this one has no pattern and it goes on forever makes it irrational. So that is the one you would want to select. Okay. Number 11, how do you prove that this has no solutions? Again, no solutions is same slope but different y-intercepts, right? So 2 ways of going about this. Okay. I'm going to take that 4x to the other side. I'm just going to basically convert this standard form equation into slope-intercept. I divide by 5 on both sides, and I end up with y equals negative 4/5 x plus 12/5. Okay, so that's one, right? I've got my slope of negative 4/5. Hopefully you are looking at these equations and kind of seeing what's the same about them, right? And kind of anticipating what's going to happen. Okay, but I do the same thing here. I subtract that 4x. I end up with 5y equals negative 4x plus 6. This should look very familiar from the last problem. I divide by 5, and I end up with y equals negative 4/5 x plus 6/5. Now, what I see here is that I have the same slope right here, but different y-intercepts, right? So that is the definition of something being, two lines being parallel or having no solution, right? So we would say the same slope, but different y-intercepts means that they have no solution, right? So equations or lines, either way, with the same slope but different y-intercepts means they have no solution. There are shortcuts you can do, right? That you don't have to go through all that work, right? We've got this in the form of ax plus by equals c. If you look here to find the slope, you can just do a over b and change the sign of it. So this a over b would be 4/5, and then you make it negative, you change the sign. And isn't that what we just did here? Okay. To find the value for b, you take c over b. So this would be 12/5 for the first one, and then 6/5 for the second one. Right, but it's the same one. That slope is negative 4/5 for each one, right? And I mean, that's the exact same thing we just got, right? So just different ways to do that. Okay. So you're going to see a problem on here with both a fraction and a decimal. My recommendation is that you take that fraction and change it into a decimal. So 3/4 is 7.75. So this becomes y equals 0.75x minus 5. And then I take, this is actually really similar to, I think, number 9? Yeah, number 9 of the scooter problem, right? Where we put them equal to each other, right? Or the right side of each one, right? So I take this here and here, and I set them equal to each other, right? So I've got that 0.75x minus 5 equals 0.5x plus 2. I subtract here. Okay, that's going to get us 0.25x minus 5 equals 2. I add 5 to get to 7. And then I divide by 0.25 on both sides. Okay, make sure you're dividing by 7 on top. 7 divided by 0.25 gets you to 28. Okay. And then I want to take this 28 and plug it into one of these equations. I want to do the easier one. In this case, it's this one. So it's y equals 0.5. Get rid of the x, and I put that 28 inside of it. And I add 2. Half of 28 is 14. Plus 2 is y equals 16. So we have our x of 28, our y of 16. So our solution, where those lines cross, is 28, comma 16. There you go.